Hello, good morning all. Today we are going to see types of hash functions in unit 1 of data structures and algorithms, and that is hashing. So we will see what are the different types of hashing. So let us go ahead and see what are the different types of hashing and what is called as a good hash function as well as what is rehashing. So here we will move ahead and see what are the different contents that we are going to learn today. So this is what we will learn today. So we'll see what are the different properties of good hash functions. So when a hash function will be a good hash function, so that there will be less collision or there will be a unique index generated for each key which we insert or map in a hash function. After that, we'll see different types of hash functions such as a division method, multiplication method, extraction method, mid-square method, folding method, universal method. So these are the different types of hash functions, and then we'll see what is rehashing and the issues in rehashing. So let us go ahead and see what are the different properties of a good hash function. So when I say a good hash function, so it should be easy to understand basically. So when we see a hash function, so it is basically a arithmetic or mathematical function which accepts a key value as an input and then store that key along with its other values in a hash table, okay, at a particular index which is generated by that hash function. So the input of the hash function is a key or a value, and the output is the index or a location of the hash table, okay, where that key along with its all values or record is placed in that on that index in a hash table. So this hash table should be easy, this hash function should be easy to compute, as well as it should efficiently generate the index for each and every key which is to be mapped in a hash table. Now, second property is it should uniformly distribute the keys in a hash table. So it is okay when a hash table is of small size like 10 locations or 20 locations. But if a hash table is of size like 100 locations or 500 locations or 1000 locations, so in that case, the keys which for which a hash function is generating index, those index should be generated from all over the table. It should not happen that the keys are going to be mapped only in one corner of a hash table or only in one part of a hash table. So the problem is only one part of one corner of that hash table will be densely filled, and other part will remain empty, or there will be very few keys in other side in other corners of the hash table, right? So a good hash function is the hash function which will uniformly, evenly distribute the keys in the hash table, okay. Now third property of the good hash function, that it should always generate a fixed size output, does not matter what is the size of input, okay. So we may have the keys to be processed by the hash function of different sizes, but it should always generate the index or a location of a hash table of fixed size. Now fourth property is, if the hash function is collision free, then we can say a hash function is a very good hash function. Now it is very difficult to have such a hash function, but if it is at least can reduce the collision, then also we can say that it is a good hash function. So by generating the unique index for the input keys, so that there will be less collision or there will be no collision, so that hash function will be a good hash function. After that, we'll see the types of hash functions. So the first type is division method, where there is a simple formula to compute the index of the hash table, and that is you have to process your key mod table size. So you just have to give the key as an input to the hash function. So the formula to compute is key mod table size, and then that will give us a index of the hash table. For example, if the key is 50 and table size is 7, so we can process it like 50 mod 7, and we'll get an index 1 in a hash table of size 7. Now, if my hash table is of size 10 and the key is 349, So 349 mod table size 10. So that will give me an index of a hash table, and that is 9. Now one more example, if I have a key of 4322. So 4322 mod table size is 100. So in that table, the index generated will be 22. So on index 22, in location number 22, this key 4322 will be placed. So it is a very good hash function, and it has an advantage that it is very simple and very efficient to compute the index of a hash table. But there is a disadvantage also that most of the time it does not distribute the keys evenly in the hash table locations. So that is a problem with this method. Otherwise, it is very simple and very easy to understand and compute the index of the hash table. Now let us see the another method, and that is multiplication method. So in multiplication method, we can have this formula where we are going to catch a floor value. That is, we are going to ignore the value after a decimal point, that is a fractional value. And then the formula is table size into key into a mod 1. So what is m is a table size, a is a constant value, which is any constant value which you have to choose between 0 and 1. So we can have an example here, like if my key is 1 2 3 4 5. So this is my key value 1 2 3 4 5. So it is a single value, which we want to map into the hash table. Now what is a? A is a constant value which we want, which we have to decide. So it should lie between 0 and 1. So it is 0.357840. So this is what we have selected as a constant. And what is the table size? M, which is 100. Now how to find a hash key? So this is the formula, like floor, then 100 into the key value into constant 0.357840 mod 1. So that will give me 0.5348. Then that is multiplied with table size. I will get 53.48. Now 53 is the floor value. So this is the index 53, where I can place the key value 1 2 3 4 5. So this is how we can find out the index using multiplication method. And the advantage of this method is it can work with any value or of a. That is, we can have any value between 0 to 1, which will be fixed as a constant to map the values in hash table. But there is a disadvantage also with this method, and that is it is generally suitable when the table size is a power of 2. So this is multiplication method. Now we'll see mid square method. So in mid square method, it is again very simple method where we just have to square the key value and then extract its middle value or middle digits. So for example, consider key is 60. So just square the 60 to find the hash key of 60. So 60 into 60 is 3600. So what is the middle digit? It's 60. Okay. Now if we want to find the hash key for 25, so 25 into 25 is 625, and the middle digit is 2, right? So 2 is the index. So this is how the index are generated by mid square hash function. So if the digits are even digits, so we can have two middle values. If the number of digits are odd number of digits, then we will have a single digit as a middle value. Okay, so that is index generated by hash function using mid square method. So this method is having a very good performance because a whole key is contributing to generate a hash key. Now there is a disadvantage also that if the key is very big, if the key is having a large number of digits, then its square will be again larger, right? So this is a disadvantage, but for this disadvantage we will have a solution also, and that solution is a digit folding method. So this digit folding method is generally preferred for the keys having longer length. If the key is having very high number of digits, like an example, for an example, we can consider a customer ID which is provided by many commercial organizations, like bank, account number, which is generally a key to identify customers, right? Customer records. So these customer IDs, account numbers are generally having 11, 14, 16 digits, right? So mid-square method is not good method, which because there, if that is a key having 11, 14 or 16 digits, square of that key will be again of very high size, and that will be a problem for our data types like integer data type, character or float, right? So they may not come in the range of those data types. So we can use a digit folding method for a longer or larger keys. So here we can have an example that larger key is divided into parts of equal size. So all the parts will be equal size except the last part. And then we will add those parts, and then that addition will be taken mod with table size, and that will give us the index of the hash table. So if we can take an example here where the key is of size 7 digits, like 1, 2, 3, 4, 5, 6, 7 is our key. Now, how to find the index for this hash key? In a table size of 10. So in table size of 10, we will have a single digit to divide the key into parts. So like 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. And that give us an addition of 28. And then we'll take 28 mod 10, and that give us 8. So this 8 is the index in a hash table of size 10. Now, if my hash table is of size 100, I will use a or I will divide the keys such that each part of the key will have 2 digits. So the table size will help us to decide the size of the division or size of the parts of the key, right? So if the table size is 100, we can have or we can divide the keys in the equal parts having 2 digits. So here we can have 12 plus 34 plus 56 plus 7, and that is 109 mod table size 100 equal to 9. So 9 is the index where this key will be placed in a table of size 100. Now, if my table size is 1000, I can have a division of three digits like 1, 2, 3 plus 4, 5, 6 plus 7. And then I will get 586 as an addition mod 1000. I will get 586 as a index in a hash table of size 1000. So this is how digit folding method is used, and it is preferred for the keys having larger or longer length. Now the advantage is that it is good for the keys having longer and larger length. Okay, it works very well for that situation. But the disadvantage is it is little complex to compute because initially आपको keys को divide करना है, फिर उसके बाद you have to decide the size of each division, each part, and then addition, and then again the mod operation, right? So it is little complex to compute. And there is one more disadvantage again, that this method is generally suitable when the table size is the power of 2. So these are some advantages and disadvantages of digit folding method. And the last is universal hash function. So this universal hash function actually refers to selecting a hash function from randomly from a set of hash functions, okay, with certain mathematical properties. So it is not a single hash function. So every time when we map a key, to the hash function, we use a hash function which we don't know that which hash function will be used. It is selected randomly from a set of hash functions. Like h is a set of hash functions, h1, h2 up to hn. Now, if my key is xyz, so for my key xyz, it is mapped to the hash table using a hash function h, which is selected randomly from a set of hash functions, right? So that is called as universal hash function. And so these are the different types of hash functions like division method, multiplication method, mid square method, and after mid square method there was digit folding and universal hashing method, right? So now we'll see now what is rehashing. So in the word itself you can see rehashing. So rehashing, so it is equal to like resize, reshape, restore. Okay, so re means do it again, right? So hashing again, rehashing means hashing again. So why to do hashing again? एक बार hashing कर लिया मतलब key को हैश फंक्शन को इनपुट दिया, हैश फंक्शन ने इंडेक्स जनरेट किया हैश टेबल का, उस इंडेक्स पे हमने की को स्टोर कर दिया, प्लेस कर दिया। अभी रीहैशिंग क्यों करना है, मतलब फिर से हैशिंग क्यों करना है? Because there are some reasons behind rehashing. That is, if the current hash table is full. Second reason, if the load density or load factor of the table reached to its threshold, reached to its limit, or if there are some keys which could not be placed in the hash table properly. So these are some reasons when we change the size of the table to its double size. That means if the current table is of size 10, we change it to 20. If the current size of the table is 100, we change it to 200. If the current size of the table is 500, we change it to a table having 1000 locations. So when we change the size of the table, what we have to do? We have to do rehashing. What is that rehashing? How to do this rehashing? Initially create a new hash table of size double of the current table, and after that insert each key from the old table to the new table, and that is called as a rehash. Okay, so use the hash function to again map, to again hash the keys from the old table to the new table, right? So why we should do this rehashing? Initially, first reason is we have changed the table now, so we want to map the keys from old table to the new table using a hash function. But hash function uses what? Table size, right? So table size previously was different and now it is different, right? So this is rehashing. When a table becomes full, or it becomes more dense, its load density or factor reaches to a particular limit, we change the table size. Okay, we create a new table of double size. Okay, instead of changing the table size, what we do, we create a new table of double size, right? And then from old table, the keys are stored into the new table using the hash function, and that is called as rehashing. So if hashing is mapping of the keys to the hash table using a hash function, so rehashing is what? Remapping. Okay, we can say, or rehashing the keys from old table to the new table, right? So that is rehashing. So this is all about today's lecture, and in this lecture we have studied what are the properties of a good hash function, what are the different types of hash functions, division method, mid square method, digit folding method, multiplication method, and universal hash function. And in the last we have seen what is rehashing, why we do it, and how we do it, right? So thank you. I hope you have enjoyed the contents of today's lecture. Thank you.